So about the session, first I will introduce myself, and I will then turn off the camera for the bandwidth. And actually, as you know, this SQL Server is old already for almost 1.5 years, so almost 2 years, and there is no so much of new function actually. But we will try to do some overview about new stuff that was introduced in the last, let's say, from 2016 version of SQL Server.
Okay.
So about me, I was for many years a developer and mostly programming in ASP.NET using C#, of course, and I was using also many other technologies. Also Oracle, a small part of my life, and Clarion and WinForms and etc. So actually I started to use SQL Server from version 2000, and later on I oriented myself in development and optimization. Last 9 years I'm working for a company called Span, and actually it's a big company in Croatia. And we are also doing business on every continent of the world. So it's pretty nice to work for them. And yes, as you already told, I'm leading the Croatian SQL Server user group. And also I started to organize SQL Saturday events in Croatia. But now PAS actually closed. So today, actually, or yesterday, there was a news about that actually Redgate will take over the PAS. So maybe SQL Saturday will continue to go, but it doesn't matter really because we already have plans for our next event here in Croatia. So it's not important how it is called actually. And yes, I'm also the co-founder of Data Weekender Conference. Magnus before me is also one of them. And I am also writing my blog about SQL Server. So please just contact me if you like. Okay, I will stop the camera so you can see more clearly that. So actually, most improvements since SQL Server 2016 up to date is being introduced on functions related to string manipulation. And we will see some of them, of course. And then in addition, there are some news related to other segments. And of course, this session is related to some new functions and features, like it was described in my session, and not about performance tuning, for example, enhancements, because you have a lot of them also, like intelligent query processor and etc. And this session will not cover these parts. So strings was new from SQL Server 2016. You have, for example, string split, and it is a table value function for splitting strings values by a separator. It has multiple usages. For example, you can use it for parsing input parameter of a store procedure or something else. The function returns a single column table with fragments, and the name of the column is value. Return type, of course, depends on any of the input arguments, and you can use it in the not only in the select part of the statement, but only in the where or from, for example, by using join or cross apply. So I know that actually there are many theories and approaches and solutions for splitting strings in SQL Server before the string split. The one I personally prefer was using XML. And of course, if you want to find some alternatives, you can find a great article by Aaron Bertrand on SQLperformance.com. And later on the demo, we will see how string split is performing. So SQL Server 2016 also introduced us string escape. And actually, the function is for escaping special characters by any rule, while the rule is JSON, of course. So only JSON rule is supported. And the reason for that is also because SQL Server 2016 introduced JSON support, and then it was logical to introduce also string escape for that. The third one is format message, and actually it's an old syntax. It was actually enhanced in SQL Server 2016 to accept the optional message string argument. And this means that you can use your own string to build a message. And for example, if you are a developer, then maybe you like to use something in C#, for example, string format, and then actually you can use format message, and you will have almost the same thing like using string format in C#. Okay, let's jump on the first demo here. Hope you see the screen. Let's check it out. I think yes. It is readable, Simon. So string split. You have here ingredients of cocktail, and we are using string split to get this value, and the result is pretty much fast forward of that. But one thing that actually I don't like in string split is that you cannot use two characters in the separator. So the separator must be only one character here. So you will get an exception or error if you are using more than one character. And this was actually possible to implement in some custom solutions before. Of course, if you have, for example, one character, and this is a valid separation, what will happen in this example here? Let's check it out. You will get, of course, an empty string. So maybe this is also something that you must have in mind when using string split.
Can you just increase your font size a little bit? We're getting comments, yeah, if that is possible. Yeah, that should be helpful. Yeah, thank you so much.
No problems. So as I told, here you have the separator character, and of course, have in mind that you will get an empty string for the result in that case. And two characters are not supported for a separator, and that's something that could be a little bit better, by my opinion. Okay, so for example, imagine, for example, that stock items ID are input parameter of store procedure, and I want, for example, to get all invoice lines for this stock items ID. So actually, I can use in the where statement, selecting the values by using split string. So if I run this code, then I will get all the invoice IDs with this stock items ID. And this is one example of the usage of this function. Of course, there are many more of them. And let's actually see the comparison of the performance between the old approach and the new approach. So actually, I prefer the one with XML, and this is this function for splitting strings with XML approach. So let's see if it is working. Of course it is. I get 3 items here, and I split the result by using space. I will turn on the statistics and whatever needed. And first, I will run this code by using the old function with XML. And secondly, I will use the split string approach. Okay. So let's check, run this code. The result is not so important, it is the same dataset, of course. But now let me zoom it in a little bit. Okay. If I go to, for example, execution plan, you will see that the first statement with the old function and XML used 64% of the whole batch, and the second one used only 36%. And if you look at the messages here, you will see that the first query used also a temporary table to be able to perform, and there was 28 scan and 227 logical reads in TempDB to be able to execute the query. And it was a really small data set, and totally we used 60 milliseconds of CPU time. And in the second example, actually you cannot see anymore the temp table, only the primary table with only 16 logical reads. And of course the CPU time is seems like it's our execution time 31. Okay, maybe we should run it again, but it's slightly much better, of course. Yes, it's something like 0 milliseconds for the second query. So the string split, it's a really good implementation of this problem. Okay, string escape, as you know, you can use it by an escaping rule, and the only rule supported for now is JSON. So we have actually here a string value with slashes, backslashes, enter, characters, and whatever. And I can show you that actually here the result is an escaped string value. And actually you can use this escaped characters string for JSON. So since this function is introduced in the same version of SQL Server when JSON was introduced. The third function was the format message, actually. And take a note here that I have 2 string values and I want to concatenate and make a whole sentence of this. So for example, somebody, we should not name it, likes some drink. And this is the old approach by using the plus between. Of course, it's working, but it's not so simple, because if, for example, I want to add a number in this formula, then it is required actually to cast this value. And this is the way to get this result, of course. And we have another complication, because if we are using the null values in all of that, we will get normally null. So you know all that null plus something is always null. So it's impossible to add null to something. So here is the bulletproof solution. Of course, see this big text here. So I'm checking for is null for every variable. And of course, I'm casting every number to a string, and this is actually the bulletproof solution of this. And it's more simple, of course, with format message. Is pretty much like the C# code. So I have here a string, resulting string, and I am using these placeholders. Also, I specified in the placeholder if this variable will be formatted as a string or number or something else. So actually, you have more options, and it's then from the second parameter you are using variables, and this is the way to get this result. What will happen with the null value? So it's the same example as before. Remember, then I was typing is null and parsing, casting the number. So actually here, I will zoom it. As maybe you can see, the null is represented by null. So, okay, it's not ideal, but it's better. And also, I think that you notice here that the casting is also required, because let's see what will happen if we are not using the cast. Let's run it, and we get a severity error. So actually casting is still required, but it's easier to accomplish the task. And of course, one nice example, if you want to fastly generate drop statements for all tables in your database, you could use format message for that. Okay, so that's about string functions in SQL Server 2017. 16, sorry. Let's jump at SQL Server 2017 now. So the first function, it's trim, and it's not so complicated, of course. Remember that before trim, you were able only to accomplish this by using ltrim and then in combination with rtrim. And trim removes space characters from both sides, meaning at the beginning and at the end of the given string value. So you could, for example, use some custom CLR function, for example, by using C# trim, but maybe this isn't the best approach for this task. Secondly, string aggregate function. It's of course for string aggregation, and it's pretty much the opposite from string split described earlier. I know that also for this purpose, there are many theories, approaches, and solutions. And I prefer by using XML and stuff in combination with stuff. And there are also many handy articles on internet in the compartment of methods to aggregate strings. And maybe there is a very good one on Redgate Simple Talks by Enid Sam. Sorry if the pronunciation isn't right. Translate. If you think that Translate has something in common with language translations, then you are completely wrong, of course, but it would be cool, I admit. The function translate replaces multiple characters inside the given string value and cannot be used to replace a character with an empty string, for example, like using replace. This was, of course, possible by using the older replace approach. Later on the demo, we will see what's the point of this. Concat VS. So actually, concat is an old function introduced in SQL Server 2012, and it returns a string that is the result of concatenation of two or more string values. The new function, concat VS, it's introduced in SQL Server 2017, and it concatenates a variable number of arguments with the delimiter specified in the first argument, so the separator. If you need the same separator between two or more strings, then the concat VS is the command you are looking for. Demo. Okay. So trim, it's simple. You have spaces on the beginning, spaces on the end. This is the original value, union with L-trim, R-trim. This was the old approach, and of course, now you can use only this trim. And the result is pretty much the same. I will not zoom it now because you can see actually that the space characters are removed from the beginning and from the end of the string. SQL Server string aggregate. So I have 3 words here, and I want to aggregate by using the space between these letters. So actually the result of this is an aggregated value. Okay. Let's try to make a real example of this. And here we have an error. Why we get the exception here? Because this customer name is of data type nvarchar and only 100. So nvarchar 100 length. And so actually SQL Server was thinking that's impossible that the result string will be greater than 8,000 characters. So if you want actually to use string aggregate, for that case, you must first cast the column to nvarchar max. Because if you are using the string aggregate with aggregating nvarchar max, then the result string will be also be nvarchar max, and then you don't have errors. Let's see what's happening when you are aggregating null values. So I have here 3 words, and one of them is null, the actual DB null. And the result is nice because actually null values are ignored. So also take in mind if you are using this that maybe sometimes this will make you problems, but maybe not. Okay. Here we have, for example, for every customer ID, we get all the invoices for this customer. If we run this code, it's pretty much simple. So customer number 1 has all these invoice IDs. Customer number 2 has all these invoice IDs. But why I'm showing this to you, the point is that here you actually don't have the guarantee. It's not clear how the resulting invoice list will be sorted. And if you actually want to be sure that this is sorted by something, then you must use this here syntax. So you string aggregate the invoice ID. This is the delimiter, and also within group order by invoice ID. And now if we run this code, we will get pretty much the same result, but now we for sure know that actually this list here is sorted from the smallest to the largest value. Let's compare performance. Let's turn some statistics. So the first approach is by using XML and stuff. Maybe you know this approach. And the second one is by using string aggregate. Okay, let's run both of these. Let's see the execution plan for the old approach by using XML and stuff. Used almost 100% of the whole batch. It's not actually 100%, but near of that. And if you look at the messages, you will see actually that the first time we have some 663 logical reads, and execution time was 234 milliseconds. And secondly, we had only 63 milliseconds. So the string aggregate is working pretty much well, I think. Okay, translate actually replace characters, and maybe it's hard to understand the syntax here, but as you can see, you have the input string value, and here you have the character you want to replace, and here is the character with what you want to replace this. So it's always by one character, but for example, this is not supported. You cannot replace some character with an empty string. So actually the two variables must be of the same length. And okay, before using translate, you can use replace. So this is the syntax by using replace. And of course, this is okay. So actually, we can replace something with an empty character by using replace, and this is not supported in the translate. But for example, the SQL translate allows us to replace more than one character at the same time. So we are replacing this bracket with this bracket, and this character here, or bracket with this character here. And before the existence of translate, this was the way to achieve this. So you should use twice the replace function. Okay, and the result is the same. Okay, let's see the concat. So concat is an old function. As you know, this was the usage of this. You have the variable, some one or more arguments, and actually the result of this action is the concatenated string of this all. And it's pretty nice because the concat allows us that actually we don't need to make the casting, of course. How it's concat performing with null values. This is always interesting to know. So null values are totally ignored, like nothing, like string empty, for example. So this is also something to take in consideration. Okay, let's try to concatenate the same drop statements for every table in the databases, like we did it before, of course. And this is the way to do this. But okay, concat is an old function, and now SQL Server 2017 give us concat vs, and the point of this is that actually you get firstly an error if you try to run this with 2 parameters, so at least 3 parameters are required. And let's see. So what I did, I actually was using concat vs. This is the delimiter. So concat.vs use the same delimiter between every column after that. So all these columns will have the same delimiter. And notice here in this example that actually I get something similar to a CSV file. Okay, but we have only one small problems. Notice that actually here I want to put a null value in between. And if I run this, and if I want, for example, to use this like a CSV data file, I have a problem because it's not valid, because you have 3 columns and only 2 values here. And actually this CSV, it's not so great. And if you want to use null values, then it's required to check for the is null. Okay, and now this would be a valid CSV data file. So the point is that you must always know your data and how a function returns a certain data type, for example, like null. Okay, SQL Server 2019. You remember the well-known error message: string or binary data will be truncated. And it can be very frustrating because it was almost impossible to detect what insert statement or record is the cause of this issue. Imagine, for example, that we are trying to insert some values from another table or maybe a complex select statement. But now Microsoft team did a great job in SQL Server 2019, because this error message is changed, enhanced. So now we know some basic parameter of the error. For example, the table, the database, also the table in which the insert error occurred, the destination column name, of course, and finally the value, or the part of the value that was the cause of this error, for example, XXX. Just keep in mind that the error number changed from 8,152 to 2,628, and if your code refers to the old error number, you can turn this feature off by the command you are seeing on the bottom of the screen. So alter database scope configuration, set verbose truncation warning to off. Okay, UTF8, it's also something introduced in SQL Server 2019. So before SQL Server 2019, storing some ASCII characters was limited. SQL Server supports Unicode characters in the form of nchar, nvarchar, and ntext data types that are using UTF-16 encoding. The penalty of this approach was that you need to pay the price for more storage and memory, because you had to store all the data in Unicode UTF-16, even when you need only ASCII characters. UTF-8 is the dominant character encoding system for the World Wide Web, of course, and it's used in over 90% of all web pages. UTF-8 database support allows us application internationalization without converting all strings to Unicode. UTF-8 support in SQL Server 2019 is implemented as new collations, and in total you have 1,553 new collations that you can choose for your database. You can identify them because they finish with the UTF-8 suffix. This is one example of that. So we are actually trying to store in the database the Russian translation of the phrase SQL Server supports UTF-8 collation. And if Google Translate does not lie to us, it should sound like visible here. Notice also that the non-UTF database on the left side, the result, we actually lose the Cyrillic characters when not using nvarchar data type. And they are, of course, on the right side. When using UTF database, the result is now correct, and we see the Cyrillic characters in both data types, so varchar and nvarchar. Also, take the look at the data linked value column, and you can notice that there is a slight improvement in the consumption of the space needed for storing Cyrillic characters using the UTF-8 encoding. So actually less space means faster performance, because still the hard drive is the bad performing component of the system. Okay, string and binary data will be truncated. Here I have a small table, data, I have two columns, and I'm trying to insert something. And of course I get this error, and I really don't know what happened here and what's the problem here. And it actually takes me a lot of time to investigate. But if we are using the SQL Server 2019 with the same example and trying to insert the same data, you will see actually that the error message is better, and you will get string or binary data will be truncated. And now you know the database, the table, the column, and also the part of the truncated value. So if I take a look here, I can find actually that this is the problem. And why is this problem? Because Daniel's length is more than 6 characters that actually I was planning to insert into the database. UTF-8. So these are the new collations. Like told before, you have 1,553 new collations, and all the names finish at UTF-8 here in the database. So let's create fastly an example for that. Okay. I created two databases, one with UTF-8, one without it. And notice here that this is actually the result of that. Just let me try to zoom it for you. Hope that you will see it. So the first two examples are the non-UTF-8 database. So if we are using the non-N varchar data type, we lose the characters here. And the second approach, it's better, but it takes much space because 78 length of the data is here. But when using the UTF-8 supported database, then also the non-N varchar data can be stored here, and also the length of this data is smaller. So this is faster. Okay. Compress and decompress. So it was introduced in SQL Server 2016. And maybe you know that SQL Server already supports row and page compression of the data. And for example, compress function isn't the replacement for them. The function returns the data type of var binary max that represents the compressed content of the input. The function actually uses gzip algorithm for data compression, and compressed data cannot be indexed. So it's actually recommended to use it on rarely used data, maybe some log data or XML, because the data is not simple readable or usable if first not decompressed. On short text values, the compressed data could be used more space than the original data. This is a normal behavior, like the file compression of really small files. What is decompress? Decompress should be the exact opposite of the compress mechanism, or maybe not. I want it to be, but it's not. So the function return the data type of var binary max data type. And if you like to get the original value, you must first cast the data in the original data type. So, or maybe you know how to read the var binary max by yourself. Okay, let's jump on the demo. So I have here a really big string over ellipsum, and this is the result of compression. So it's var binary max, and it was used gzip algorithm. So let's see how it was efficient. So the compression rate is 62%, and it's pretty much good this. But what if we try to compress a really small string? Notice that actually the compression rate of the really small string is minus 20%. So actually the compressed string used more data than the original value. Okay, now I will show you the compartment between row and page compression. I created some test data. So let's see how they look. So actually this is non-compressed data in the first table, and this is compressed data. So first we will use this original table, non-compressed, and let's see the original size, then the row compression, page compression, and finally the compressed data. Let's run it. So the original size is 43 megabytes. So row compression and page compression are almost the same. So 22 megabytes. And the compress function generated 32 megabytes of data. So it's not so bad, but you maybe must not use this always, because you have some performance problems. Also, I have some XML data here, and I compressed them also. And if we compare the space usage, you will see actually that the original XML was using 156 megabytes and the compressed 80 megabytes. So it's pretty much good, but always you have these problems with performance. Okay, the compress. So I'm here compressing and then decompressing the same value. And the result of that is, of course, something that's not readable, because actually I wanted to get a nice value. And to be able to get the original value, you must, of course, cast the data to the original data type. So first I'm compressing and then decompressing, and of course I'm casting this as nvarchar max. And you have, for example, problems if you make some, if you don't know your data. So I actually started from nvarchar max, and I wanted to finish to varchar max. And this is the first funny example. So I get here something that's actually not like original value. And this is even better here, the second one. So I started from varchar max and I'm finishing with nvarchar max. Let's run it. And now it's a totally mess here. Okay, let's see some performance of the compress. So I have in the first table, I have non-compressed data in XML, and in the second table, I have compressed, but it's also XML. And let's run this fast. So if first we look at the execution plan, it actually say that 66% was used by the non-compressed data, and only 34% on the compressed data. And we all know that this is not the true, because decompressing it's time consuming. So the first query take 110 milliseconds, and the second one 1 second, so 10 times more. But why this? Why is this value? So the first query had almost 20,000 logical reads, and the second query has just a second. The second has less logical reads. So SQL Server actually was thinking that the second one with the decompress is better. And now I think that my time is over, and I want to finish. And thank you very much for this.